Thermal energy, as we know, can be used to perform work. In this chapter, we study the laws that govern thermal energy. In winters, we often find ourselves rubbing our palms together. This is because rubbing them together leads to the production of heat, which makes us feel warmer. Thus, work is done by us, and the result is heat energy. The converse of this process is made use of in steam engines, where heat energy from burning of fuels results in work being done. The definition of heat has varied considerably over years. In older times, heat was believed to be a fine, invisible fluid which occupies the pores of an object. This fluid, then known as caloric, would flow from hot bodies to colder ones when the two came in contact. This flow would continue until the caloric levels in both bodies would be the same. Thus, the older concept of heat had no relation with work done on or by the body. This concept, however, was discarded as time passed, since it could not explain heat transfer by means of radiation. Its place was taken by the modern concept of heat, given by Benjamin Thomson. Benjamin Thomson, who also came to be known as Count Rumford, observed that the firing of brass cannons made the cannons extremely hot. Indeed, the heat produced was often enough to boil water. More importantly, he observed that firing the cannon more resulted in greater heat being generated. In older times, drills were driven by horses, who would turn the drill over and over again. He also observed that the heat generated in the drill was dependent on the amount of work done by the horses in turning the drill, but was independent of the sharpness of the drill. But according to the older concept of heat, this should not have been the case. A sharper drill must have been able to scoop out more calorific from the pores of the object being drilled, and hence a sharper drill should have gotten hotter than a blunt one. This led the Count to the conclusion that heat was in fact a form of energy, and what was actually being observed was the conversion of work to heat energy. The study of this interconversion of energy is what we know today as thermodynamics. Thermodynamics deals with study of the macroscopic characteristics of a system rather than the microscopic aspects of it. For example, when we describe a gas in thermodynamic terms, we describe parameters like pressure, volume, temperature, mass, etc., instead of the number and position of the molecules and their velocities, as we would when describing it microscopically. Thermodynamics is also very different from mechanics. While mechanics deals with the motion of particles when acted upon by forces and torques, thermodynamics concerns itself with the internal macroscopic state of the system.